Alright guys, we are going over our quiz. I'm going to try to make this quick, so if you need to pause, reread what I did, jot some things down, that would be smart. Okay, so this is for 4.1 through 4.3. 4.1 is all about that slope-intercept form, y equals mx plus b, where m is slope and b is y-intercept. 4.2, that was all about point slope form, so that's y minus y1 equals m times x minus x1. M again is slope, it's always slope. And then x1, y1 is just another way of saying to pick a point. So I'm going to say that'll be some number, comma some number. You should always know that your ordered pairs or coordinate points are x, y. Now for 4.3, we learned about perpendicular lines. Perpendicular lines have opposite, reciprocals, slope, and parallel lines. Oh, let's restart this. There we go. And parallel lines have same slope. Okay, so those are just our general things that we learned. We're going to go to number 1. It says to write an equation of the line in slope-intercept form. So for 1 and for number 2, what are we going to need? We're going to need m, which is slope, and we're going to need b. Okay, looking at a graph, it's pretty simple. All you gotta do for number 1 is count that rise over run, which is 1 over 1, 2, 3. So m is 1 over 3. And b, we can see right here that our y-axis meets our line at 0, 2. And our y-coordinate there is 2. So our line for number 1 is y equals 1/3 x plus 2. Okay, now for number 2, our slope, something tricky, it's pointing down, we're going downhill. So slope for m is negative. Now we're going to count our rise. Our rise is 1 over 1, 2, 3, 4. Negative 1 over 4. And again, that intersection point is 3, so b is 3. Our line is y equals 1/4 x plus 3. Okay, that one should have been easy for you guys. So if you're struggling, you need to be studying. This next one, write an equation in point slope form of the line that passes through the given points. So we need to look at this, and we need m. And we're going to need an x1, y1, because we're using point slope form. There we go. So for m, we have to use that slope formula. So y2 minus y1 over x2 minus x1. Okay, so our top here is 6, which is our y2, minus 4, which is our y1, over 5, which is our x2, minus 0, which is our x1. 6 minus 4 gives us 2. 5 minus 0 gives us 5. Our slope is 2/5. Okay, so from now we gotta find our x1, y1, so we're just gonna pick a point. I'm gonna pick 0, 4. So now we're plugging that in. We're going to do y minus y1, which I chose to be 4, equals m, which is 2/5, times x minus x1, which is 0. So now we're going to just solve and distribute. 2/5 times x becomes 2/5 x. 2/5 times 0 is 0. We're going to leave that off because we do not need that. Then we're going to add 4. These will cancel. Our line becomes y equals 2/5 x plus 4. Okay, step 1, what did we do? We found slope using the slope formula. Step 2, we plugged in our x1, y1, and our m. We distributed and solved for y. Okay, now if you need to look at this, you're going to need to pause it because I'm about to erase it. Okay. So for number 5 and number 6, we're going to run through the slopes real fast. We're going to do -2 minus 2. That's -4. We're going to do -2 minus 3. That's -5. Any negative divided by a negative makes a positive, and in this case it is 4/5. So now we're plugging in y minus y1. I'm going to choose 3 and 2. Equals m, which is 4/5, times x minus 3, which is our x1. Okay, from here we're going to have to use our calculators. So if you have trouble with this calculator math, what you need to do is use this and pay attention. So there's 2 ways to do it. You can always type calculator fractions by using parentheses, your number, top number, numerator, divided by your bottom number, your denominator, parentheses, okay? But these parentheses have to be there. They are so super important. That's how you tell your calculator what to do. You can also press the button, math. That's right below alpha. You're going to go over to frac, and that is on the top. So you're going to have to press this arrow button all the way over. And then you're going to press the number 1 n-d, and you'll type your numerator and then you'll type your denominator. Okay, so I'm going to use that 4 over 5. I'm going to multiply that by -3, and I have y minus 2 equals 4/5 x minus 12 over 5. Okay. From here I'm adding 2 to both sides. I get y equals 4/5 x, and then -12/5 plus 2 gives me -2/5. Okay, so make sure you're using those calculator buttons. You can totally use the math button, or you can just use parentheses, but if you don't put parentheses, you will get it wrong, so that's my warning. Alright, for number 6, I'm going to give you another quick run through. So for m, we have 7 minus 6, that gives us 1. Then we have 3 minus 4, that gives me -1. Our slope is -1. Now we're just rewriting y minus, let's use 4 and 6, minus 6 equals -1 times x minus 4. We're going to keep y minus 6, we're going to distribute on that side, so -1x, or -x, -1 times -4, that makes a +4. We're going to add 6 to both sides, and we will get y equals -x plus 10. Okay? So there's just 2 major steps. Find slope using slope formula, plug in, and distribute. Okay? So these are just like above. They're just like above. So what all I'm going to review is how to find your 2 starting points. Okay, we learned that it is always f of x equals some number, some y, some output. So for 7, 3 is x and 0 is y. 4 is x and 6 is y. Okay, so you can do 7 and 8 from here, just like the above problems, or we can use slope-intercept form, which are the same steps for m. We're doing 6 minus 0, 4 minus 3. We get 6 as our slope. Now if you're going to use slope-intercept form, all you have to do is plug in x and y. So I'm going to use 3 and 0. So we have y equals mx plus b. So I'm plugging in 0 for y, 6 for m, 3 for x, plus b. And all this becomes is 0 equals 6 times 3 is 18 plus b. We have to subtract 18. Negative 18 equals b. So our equation is y equals 6x minus 18. Okay? So if you feel comfortable with point slope form, use that. If you want to use this because you think it's easier, you're welcome to. Okay. Alright, for 9 and 10, we did this in class together. You're going to find your slope. For each of these, I'm going to say a slope, y2 minus y1 over x2 minus x1. We're doing 13 minus 10, which is 3, over 4 minus 2, which is 2. B, we have 12 minus 9, which is 3. 6 minus 4, which is 2. For C, we have 9 minus 10, that's negative 1. 4 minus 2, that's 2. Okay, like I said above, parallel lines. Parallel lines, I'm going to put parallel, have the same slope. Perpendicular lines have opposite reciprocals, which means it's going to be the opposite sign, and the fraction is going to be flipped. So looking at slope A, B, and C, I can tell you right now that A and B are parallel lines. And now if I look at C, C is not opposite reciprocal because it's 1 and 2, not 2 over 3. So all that we know for 9 is that they are parallel lines, A and B. For number 10, step 1, find slope. But how are we going to find slope? You have to solve for y. Solve for y and find m. Okay, so let's solve A real quick. We have 2x plus 6y minus 3 equals negative 3. We are going to subtract that 2x, and we will get 6y equals negative 2x minus 3. Our last step, we have to get y alone, so we're dividing by 6. And when you divide on the right side, you can't just divide one part. This minus sign means that you have to divide the first and the next one. So now we have our final line, which is y equals negative 1/3, because you have to simplify, minus 1/2. Okay, so for A, what is m? M equals negative 1/3. Okay, now if you need to pause, go ahead and pause because I'm going to erase. Okay, for line B, Okay, so I got cut off, but we are comparing slopes. So for A, we got -1/3. For B, just by looking at this, we know our slope is 3. And for C, we have to solve for y. So we have -6y plus 18x equals 9. Our first step is going to be to subtract 18x. So we'll cancel. We have -6y equals -18x. And a +9, so that's +9. Our last step is to divide by -6. We have to divide each part on the right. And our our rewritten line is y equals a +3x minus 3/2. So from there we can see that our slope is 3 for C. And now we can draw those conclusions and say that our parallel lines are those lines with the same slope. So our parallel lines are B, and that is parallel to C. And then our opposite reciprocals are A to B, and A is also perpendicular to C. Okay, we're going to flip the page and work on the back. Okay, so now we're on to the back, and we are still reviewing 4.3. So that important information is our parallel lines have the same slope, and our perpendicular lines have opposite reciprocals. So we're going to write an equation of the line that passes through -4, -6, and is parallel to y equals 3x minus 8. So our important thing every time we write an equation is we need slope. And if they're parallel lines, then we know that they have the same slope. So slope is 3. And we're going to take that other information, that x1, y1, as -4, -x, -6, I mean. Okay, so our point slope form is y minus y1 equals m times x minus x1. So we're going to plug in those points. We get y minus -6 equals 3 times x minus -4. And of course, I'm going to simplify that because subtracting a negative is like adding a positive. So we have y plus 6 equals 3 times x plus 4. And finally, we are distributing and solving. We get y plus 6 equals 3x plus 12. We subtract 6 from both sides and get y equals 3x plus 6. And that's our new line. So for 12, we're going to do the exact same process, except we're going to write an equation of the line that passes through 2, 5 and is perpendicular to y equals 1/4 x minus 12. So it's perpendicular, so our slope is the opposite reciprocal, which means instead of positive, it is negative. We're switching 4 to the top, so we got 4/1, which just gives us -4 as our slope. From here, we're doing the same steps. Y minus y1, which is 5, equals our slope, which is -4, times x minus x1, which is 2. We're going to distribute y minus 5 equals -4x plus 8, because that -4 times -2 equals +8. We're going to add 5 And we'll get our new line as y equals negative 4x plus 13. Okay, so now we're on to 13, our first word problem. So with our word problems 13 and 14, we're still going to use the same information. The point slope form, the y-intercept form, these things that we know, we're just going to use. So in 1960, the world record for the men's mile was 3.91 minutes. In 1980, the record time was 3.81 minutes. We're going to write a linear model that represents the world record for the men's mile as a function of number of years since 1960. So they're asking for a linear model, which we know is a linear equation. So sum y equals mx plus b. Okay, but it's our job to find that equation. So what do we need? We need to figure out that a function of x, in this case, is a function of years since 1960. So since 1960 is x, and our y is then the record in minutes. Okay, so what are our information together? Well, we're going to find our x and y's. So they give us in 1960, the world record was 3.91 minutes. So we know y easily is 3.91, but for x we can't put in 1960 because that's a year. And it's specifically how many years since 1960? Well, if we're still in 1960, that's 0 amount of years have passed. Now on to the second point, we have 1980. So since 1960, how many years has passed? 20. And then our record time that year was 3.81 minutes. So just like every linear model, linear equation, we need slope. So how do we find slope from 2 points? We're going to use our formula, y2 minus y1 over x2 minus x1. We're just going to plug in our values. 3.81 minus 3.91. Over 20 minus 0. This gives us a negative 0.10 over 20, which when dealing with real world situations, we just divide that out and make it negative 0.005. From here we have slope. All we have to do is either choose point slope or slope-intercept form. And we're going to plug in our m. So our m is negative 0.005 x plus b. Now we're plugging in our x and y, so I'm going to use 0 and 3.91 for our x and y. So we'll get 3.91 equals negative 0.005 times 0 plus b. Okay, 0 times anything is 0, so we're going to get 3.91 equals b. So we'll rewrite this and we'll get y equals m, which is negative 0.005 x plus 3.91. And that is our linear model. B is just saying use the model to represent the record time in 2000 and predict the record time in 2020. So all we have to do there is find out what is our x. So if it's year 2000, how many years since then has it been? Since 1960. Our x would be, that would be 40. Okay, and then predict our record time in 2020. that would be an additional 40 years, well, 20 years. So since 1960, x would equal 40 plus 20, 60 years. So all we have to do from here is plug it into our formula. So our record time for y would be, let's plug these into our calculators. So for y, for 40 years, we plug that in and we get, put that in black, 3.71. And then for another 20 years, it's going to go down 0.1, so you get 3.61. Okay, so there all we did was we found our information. What was x, what was y? We found our slope when we plugged it in. For 14, we're going to do a very similar process. Oops. Here we go. So you pay a processing fee and a daily fee to rent a beach house. The table shows the total cost of renting the beach house for different numbers of days. Can the situation be modeled by a linear equation? Explain. What is the processing fee, the daily fee, and you can spend more than $1,200 on the beach house rental. What is the maximum number of days you can rent at the beach house? Okay, let's start from the beginning. We are paying a processing fee and a daily fee to rent a beach house. The table shows the total cost of renting the beach house for different number of days. So let's talk about what's x and what's y. Well, how much are you going to pay? Well, you don't know until you realize how many days. So your days is independent and your cost depends on the amount of days that you stay. Well, now that we know x and y, we figured out that days is independent variable and cost is the dependent variable. We're going to talk about A. Can the situation be modeled by a linear equation? Okay, so when we're given a table, we know how to figure out if something is linear. All we're going to do is check for a constant rate of change. Days always change by 2, and cost always changed by 204. Okay, so for A, we're going to say yes. And I'm just going to say constant rate of change. So what is the processing fee and what is the daily fee? So processing and daily fee. So the daily fee is how much is being multiplied by our x, right? Because the days is x. So what's being multiplied by x? And then what's that extra processing fee, that unknown? Well, right there we described M is our daily fee, and B is that processing fee that everybody gets charged no matter how many days you go. So all we're going to do is we're going to take two sets of points, 2 and 246, and 4 and 450. We're going to find our slope, which we already know is going to be 204 over 2, which just equals 102. And we're going to take our y equals 102x plus b, plug in x and y, and we get 246 equals 102 times 2 plus b. Now I'm just going to simplify. 246 equals 204 plus b. Now we're just solving. Minus 204 on both sides, and b equals 42. So what's our linear model? What's that linear equation? It is, I'm going to write it down here, y equals 102x plus 42. So if you can spend no more than $1,200 on the beach house rental, what is the maximum number of days you can rent at the beach house? So we know our cost is y. So if we can't spend no more than $1,200, well, $1,200 is on the left side of our equation. And it wants to know how many total of days we can work. Well, days is our x. So all we have to do is solve. We're going to subtract 42. And I'm going to make some room. When we subtract 42 from 1,200, we are going to get 158 equals 102x. Now we're just going to divide by 102. And divide by 102, and we get 11.35 equals x. And if it's whole number of days, you cannot spend a whole day and also spend 0.35 of a day. So we're going to say our maximum is 11 days. Okay.